Hey, we're here. Go to math.com, click on the calculus. Let's go down to concavity. I believe we're doing 9-2. Looks good. Looks a lot like 9-1. Okay, kinda. So as you can see here first, so it says find the concavity. Here's a graph of f of x. Of course, we can look at the graph, right? This looks like concave up and then concave down, right? So let's remember this. F of x equal to negative 2 over x. F of x is equal to negative 2 over x. So we have f of x is equal to negative 2 over x. So the first thing we want to do is actually, let's rewrite this. Let's rewrite, okay, so we can take the derivative, because we don't want to use the quotient rule on that. If we have a constant in the numerator, right, we just bring the denominator up. Okay, that's a smart thing to do. So here we go. We got f prime of x is equal to, let's take that negative 1, bring it out front. Negative 1 times negative 2 is 2. Subtracting 1 from the exponent, and there you go. Alright, and then we're going to do this again. F double prime of x, take the negative 2, bring it out front. You get negative 4 x to the negative 3. Now what we'll want to do is rewrite this with positive exponents. So we have negative 4 over x cubed. And then what we do is we set this thing equal to 0, but as you can see there are no solutions to this equation. Okay, but that's okay because we can look at the denominator. We must always look at the denominator. And what would make the denominator 0? Well, when you plug 0 in for x, right? So we're going to put 0 right here. Now, let's do a test point, like for example, negative 1's a test point, and positive 1. We'll use that as a test point. And we're going to take that negative 1, plug it into the second derivative, and all we care about is if it's a positive or a negative. Okay, we don't really care about what the number actually is, other than if it's sign. So we take negative 1, we plug it in. Well, negative 1 cubed is going to be negative 1, but then we have a negative up here. The negatives cancel out, and you're left with a positive number. So like I said, all we care about is if this is positive or negative. So that was going to be concave up from negative infinity to 0. And then we'll do the other test point, plug 1 in. So we plug 1 in, you get 4 over 1, but then we have a negative out here, right? So that's going to be a negative number. So that's going to be concave down. Okay. Now we do have a change in concavity here at 0, and the question is, could this be an inflection point? But there's no way this can be an inflection point because 0 is not in the domain of f of x, right? It's not in the domain. You can't plug 0 in, so therefore there is no inflection point at 0. Alright, so we must at least talk about that. And so let's just do it up here. How's this? We have concave up from negative infinity to 0, and then concave down from 0 to infinity. Okay, so that's our argument. And of course you can clearly see that. Concave up, concave down. Let's hit the answer button, make sure everything's good on that. Right, concave up, negative infinity to 0, concave down 0 to infinity. Right, concave up, negative infinity to 0. Okay, looks good. Alright, well come on by, practice that, and I'll see you